the last one here, you've been given two positions, a min and a max, and you're being asked to find the actual equation. Well, this should, quite frankly, we can actually, just with the min and max, know what the equation should look like, because as long as we get one quadrant, we should be able to figure out the rest of the graph based on symmetry. Okay, so I'm just going to draw my middle here. That's about where my middle is. And actually, it's going to be a little bit lower than that. So it looks like my middle is right about there. And I need to figure out the equation. So I'm going to start with the y, the middle here, finding the middle line. Now we could start anywhere, but I'm going to find that middle line y. Where is that y? Well, I know the max is at 5, the min is at -2. What's halfway between? Well, again, this is an average. So if I want to find the middle, I'm going to find that by doing the average of those y positions. So I'm going to get 1.5. Okay, so that's going to be y equals 1.5. That's my vertical shift. Well, I can also get my amplitude. Now, what I want you to kind of differentiate, and some of you will use lengths to do this, but really we should be using position. This line is a position. If I want to find the average position, I can use this average formula. Okay, calculating the middle or average, that's a position. The amplitude is actually a length. Okay, I want to find the length or the distance between. Well, I find distances between things by differences. So I could just count, 1.5 up to 5 is 3.5, but I could also find the difference between min and max and take half of that difference, because the difference between the min and max is the distance between top to bottom, and I want to find half of that distance. So my amplitude is I'm gonna do it this way. I'm gonna just find the difference between the min and max and divide it by 2. And amplitude does not have a negative, so in this case here I get 3.5 or 7 over, I'll write it as 7 over 2 or 3.5. There's my amplitude. So these are some generalizations I can make. We can come up with some formulas later for this. So I've got my middle. Okay, remember there's sort of these 4 things I'm trying to get. I've got my middle, which is my vertical shift. I got my distance from the top to the bottom, or middle to the top, which is my amplitude. I need to figure out now my horizontal shift and period. Okay. Well, this one we've only dealt with periods of 2 pi so far, and this one happens to be 2 pi because if you look at the period is a distance, so we want to just subtract to find the distance here. 3 pi over 2 minus pi over 2 gives me 1 pi. Well, that represents half a period, so the next half gives me 2 pi, which is my period is 2 pi. Okay, but I can, again, we're going to generalize this later, but we can find our period or distance by subtracting the x coordinates. That means the b value is going to be 2 pi over t, which is 1. Okay, that's what we had in all the other equations before. So there's I've got now 3 parts here, my period, my vertical shift, my amplitude. What's left is a horizontal shift. There's lots of ways to do this, but the easiest way, if you have a choice, and you may not always have this choice, but the easiest way is to use a maximum, because the maximum is the starting position of all the cosine graphs. So that represents the starting point of a cosine graph. Okay, so the max position here. Well, if I have the option, I'm going to use cos, and then my horizontal shift is going to be equal to whatever that horizontal position is on the maximum. Okay, and again, we're going to generalize this later, but this is important to recognize now. So once I have those pieces, I'm just going to highlight them. I need those pieces to write my equation. I need my b, I need my vertical shift, okay, I need my amplitude, and I need my horizontal shift, and I can now write my equation. Y equals my amplitude of 3.5. I'm going to use cosine. My b value is 1, and my horizontal shift is going to be pi over 2. Okay, and then my vertical shift goes on the outside, plus 1.5. There's my equation of that graph. And if you want, graph it on Desmos and check it out.